Okay, in 2.3, we're going to talk about functions. Here's the definition of a function: an input-output device such that for every valid input, there exists a single possible output. The definition of domain: the set of all valid inputs. The definition of range: the set of all possible outputs. And then we need to learn function notation. So what we need to know is that y is the same thing as f of x. And we say this and we can use other letters than f, but conventionally we'll start by using f, and then the next letter we will introduce is g to represent a function. But what we need to know is that f of x and y are the same thing. So inside the parentheses is the input. So x is the input, meaning it's the independent variable. Now outside the parentheses is the output, and the output is y. Okay, so we have this line in standard form, and we're going to write using function notation. So we'll subtract 2x, get y on one side by itself, and then replace with function notation. And then we're going to describe the domain and range using interval notation. So the domain, the notation is capital D with a colon, and then we're going to use an interval notation. And negative infinity to infinity is the same thing as saying all real numbers, but we use interval notation. So this means that all x values are valid. And then the range is also all real numbers because every y value is possible. Let's talk about the vertical line test. So if any vertical line intersects the graph more than once, then the relation is not a function. So here we have a polynomial curve. There is no vertical line that is going to hit this graph more than once. So yes, it is a function. This is just a visual representation that every valid input is paired with a single possible output. So there is not more than one y value with any x value. So that's just how we visualize it. Over here we have a circle. So if you pick an x value, it is paired with more than one y value, and that means that it is not a function. So a vertical line hits twice in this situation, and that means it is not a function. So then we're going to practice input-output. So we're going to find f of 2, and when we find f of 2, we replace x. We replace x with 2. So we have x cubed plus 5x. So that'll be 2 cubed plus 5 times 2, which is 18. And then what we need to know is that is an ordered pair. So x equals 2, y equals 18. Then we have piecewise functions. Piecewise functions mean that there is more than one part to it, and the y value that we choose depends on the x value. So this piecewise function does read properly in English. You would read this as f of x is x plus 3 if x is greater than 5. F of x is 2x if x is less than or equal to 5. So remember that there will not be more than one y value paired with an x value for a function. So if we go and find f of 4 for this piecewise function, we have to check the condition to see which y value it will be paired with. So since x since 4 is less than or equal to 5, the y value is going to be 2 times 4. And that would give us the ordered pair of 2, 8. So that's what this says down here. Since x equals 4, which is less than or equal to 5, we use y equals 2x. Then we're going to practice finding the domain. So here we have a rational function. Remember, division by 0 is not defined. So if we have x minus 3 in the denominator, then x minus 3 cannot be 0. Add 3 to both sides. This says x cannot be 3. So x is possible. It is possible, or it is valid for x to be any number except 3. And then this is how we would write that using interval notation. On the next example, we have square root x plus 2. And so underneath square root, we can't have negatives. So the way to describe that using an inequality would be x plus 2 greater than or equal to 0. Subtract 2 from both sides, x greater than or equal to negative 2. And so then we're going to use a square bracket, negative 2 to infinity.